Welcome to online class. I am Dr. S. Abhinathan, Department of Mathematics, SRM Institute of Science and Technology, Kattankulathur. Today my topics problems based on Cauchy Residue Theorem. We see the first problems. Evaluate integral over c z square upon z minus 1 whole square into z plus 2 into dz, where c is modulus of z equal to 3 by, is a very important, what's the method is mentioned? Cauchy Residue Theorem. Okay. Solution. See, first one, choose. Let's assume that inside terms you take capital F of z is equal to z square upon z minus 1 whole square into z plus 2. First, step 1, to find poles. Step 1, to find poles. So what the poles means? You take denominator term equal to 0. So that is, can understand, denominator term equal to 0. So what are denominator terms? Z minus 1 whole square into z plus 2 equal to 0. Okay. This equation can be written as z minus 1 whole square equal to 0 and z plus 2 equal to 0. Okay. See, this problem is very important one thing. This one can be written as z minus 1 equal to 0. Next one, z equal to 1. Here this can be written as z equal to minus 2. Okay. So my dear students, very important, z minus 1 power, see, power 2 mean is a pole of order 2. Power 1 mean is called simple pole. So therefore z is equal to minus 2 is simple pole. Z is equal to plus 1 is pole of order 2. So, can you understand? So for the next one, we go the conditions given. What the condition is given? Modulus of z is equal to 3. This is can be written as z minus 0 is equal to 3. So what is the meaning of this? Center point 0, 0 and radius 3. Okay. So now you draw the diagrams, x-axis and y-axis. Okay. So the origin point 0 and radius 3 and this side will come minus 3. You make it to draw the circle. Okay. So what are the points is coming? 1, 2, 3, minus 1, minus 2, minus 3. So z equal to minus 2 is there in the point, lies inside the C. Z equal to 1 is lies inside in C. Okay. Therefore z equal to minus 2 and 1 is both points are lies inside in C. C from modulus of z equal to 3. Okay. So dear students, it's a very important one. First one, you choose inside term, you consider f of z, and the next step 1 to find poles. So what the poles mean? Denominator term equal to 0. So denominator term equal to 0 means we get z equal to 1 and z equal to minus 2. See, z minus 1 power 2 mean is called pole of order 2. Z plus 1 2 power 1 mean is called pole of order 1. Is another name is a simple pole. Okay. After that, given the conditions, modulus the circle is modulus of z equal to 3. Here modulus of z equal to 3. This one can be written as z minus 0 is equal to 3. So here center point 0, 0 and outer value, that is called radius value 3. So you draw the circle. See what are the points? Minus 2, 1. So both points lies inside in the C. Okay. So the 2 points is lies inside mean you want to find out the residues. Okay, the first one, residue of R1, is a simple pole. Okay, residue of simple pole. To find residues, first one, step 2. Okay, so first one, case 1. Case 1, what is that point? Z equal to -2 is simple pole. Okay, so we know that the formulas that R1, residue is R1 equal to limit simple residue means Z tends to A into Z minus A into capital F of Z. This is only called the formula for simple pole. Okay, here A value is -2. Okay, so R1 is a residue, R1 equal to limit Z tends to, what do you write, -2 can be written as mean Z minus plus 2, okay, into F of Z. And next step, limit Z tends to -2, Z plus 2 is F of Z. What is F of Z in this question? Inside Z square upon Z minus 1 whole square into Z plus 2. And this term is cancelled. I am getting, so limit Z tends to -2 upon Z square upon Z minus 1 whole square. So now Z is replaced by -2. So we get -2 whole square means 4 upon -2 minus 1 minus 3 whole square means we get 9. We get 4 by 9. Okay. And next one, case 2. Z equal to, what is the next one? Z equal to 1 or pole of order 2. Pole of order 2. You take the residue of R2 equal to, see that formulas order 2, okay, not simple pole, you write the general formula, limit Z tends to A 1 divided by factorial of m minus 1 d by dz whole power m minus 1 into m minus 1 into z minus a power m into capital F of z. These are general formulas. Here m value pole of order 2. Okay. So here a is 1. So we have substituted in the formula limit z tends to 1. So 1 divided by 2 minus 1 is factorial of 1. 2, what is the pole of order? M is here, m equal to 2, a is equal to 1. So we get d by dz into z minus 1 whole square into f of z. Okay, the next step, limit z tends to 1, 1 by 1 factorial value 1, d by dz into z minus 1 whole square into f of z. What is f of z? Inside the integral formula, z square upon z minus 1 whole square into z plus 2. So z minus 1 whole square is a cancel. Okay. So now we get limit z tends to 1 d by dz z square upon z plus 2. Okay. So numerator z there and denominator also in terms of z. So we have to apply by u by v formulas. So limit z tends to 1. So denominator term take z plus 2 whole square. The denominator term keep z plus 2. Z square differentiation mean we get 2z minus, now z square differentiation means 1. Okay, so now limit z tends to 1. So what I am get? 1 plus 1, 3, 3 plus 2, 6 minus 1 upon 1 plus 2, 3 square mean 9. I am get 5 by 9. This one called R2, residue of R2. So dear students, it's very important one thing, whichever point lies inside in the C, so that point we want to find out residues. So here I am getting 2 points lies inside, so I am finding the residue 1 and residue 2. So z equal to minus 1 is a simple pole. So it's very important one. Simple pole mean using these formulas, limit z tends to a, z minus a into f of z. After the we getting the answer is 4 by 9. Case 2, z equal to a or pole of order 2. It's very important, order, not order 1, not other any values there mean using these formulas. Okay, we getting the answer is 5 by 9. Therefore, what's the method? By Cauchy residue method, integral over C f of z into dz is equal to 2 pi I into sum of the residues. Okay, so we getting the 2 pi I into sum of the residues. One answer is 4 by 9 plus next second residues 5 by 9. Okay, so total answer is 2 pi I is we getting 1. So the final answer is 2 pi I. Do you have any doubts? Okay, I'll give one more problem. You try to do the same method. Second questions. Evaluate integral over C z minus 3 into dz upon dz upon z square plus 2z plus 5, where C is modulus of z plus 1 minus I equal to 2 by Cauchy residue theorems. Okay, so the previous problem method also try to do this problem. So what is the difference previous question and this question? Previous problem directly given the factorial, but this given the quadratic equation, we have to get the factorial formation. Okay, and it's very how to solve, we have to understand first of all solution. Assume that capital F of z is equal to, what is that, z minus 3 upon z square plus 2z plus 5. Okay, so step 1, you know that everyone, what is step 1? To find poles. Yes, good. That what's the meaning of the, how to find the poles? Denominator term equal to 0. So we get z square plus 2z plus 5 equal to 0. Using the quadratic formulas, z is equal to minus b plus or minus root of b square minus 4ac upon 2a. Okay, using these formulas I am getting that minus 2 plus or minus root of 4 minus 20 upon 2. Okay, so we are getting this one simplified, minus 2 plus or minus minus root 16, we can written root I by 4 upon 2. Okay, and 2 is cancelled. I am getting that z is equal to, what are the point, minus 1 plus or minus I2. So that points are z equal to minus 1 minus I2, and another point z equal to minus I plus I2. Okay, so I am getting 2 poles points. Okay, ma'am. So the next step, these points are lies inside the C or outside C. We want to check. Okay, so my dear students, we know that the control C values modulus of z plus 1 minus I. Okay, we know that first point we are going to substitute. What the first point? Z is replaced by minus 1 minus I2 minus 1 minus I is equal to, this one can be written in minus 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 2, we get minus 3I. So you take this always the positives, so it takes mean 2 plus 3I. Okay, see this value, what will happening mean, we get greater than 2. So this point lies outside in the C. Why mean, you know that root 2 square mean 4 plus 9, like that will come. Okay, the next point we are going to substitute in this given equation. So modulus of z plus 1 minus I is equal to, z is value minus I so what is that, minus 1, okay, minus 1 plus I2, okay, and the next one getting plus 1 minus I. So finally we get minus 1 plus 1 is cancelled, we get I, this value is less than 2. Okay, so this point is lies inside in the C.